First of all, like a little bit of introduction about me and where I work. So I work for this company. It's called Axel Springer. It's one of the biggest media company here in Europe. This is, for example, one of our first newspapers that we released 50 years ago. So it's called Bild. It's actually the one of the biggest newspaper in Germany. And today, as I said, we are a Europe's leading digital publisher. Approximately 6,000 people work for us. We have a couple of brands. Maybe in Poland, you also know some of it, like Onet, right? It's also an Axel Springer company, but also like a company like Business Insider also belongs to Axel Springer. Okay, who am I? So I work for, as I said, for Axel Springer. I work for the divisions called Ideas Engineering, which is the innovation unit of Axel Springer. And before that, I used to work for Pivotal Labs and also Idealo, a pricing comparing website, which also belongs to the Axel Springer group. I also lead Axel Springer AI, which is the applied R&D unit of Axel Springer. I actually created it. We're a team of 45 people, basically starting to drive innovation within the group. And we do a lot of projects in computer vision, voice, but also NLP. And if you're interested into our projects, you can go to ai.axelspringer.com. I also like not anymore that much, but I used to code a lot. I do a lot of open source. My team is committed to open source, so you still find a lot of code from me and also my team on GitHub. But I also write about this on Medium and other publications, from very technical articles to very business-related use cases. Okay, why do I need to do this talk today? Well, from my experience, what I've seen so far over the last 5 to 6 or 7 years in Germany, I can see that 85% of AI data science projects fail, right? So a lot of projects fail. And the reason for that, there's a lot of reason for that. But today I actually want to do this talk, basically how you can actually use lean startup approaches basically to minimize those project failure, because there's a very high chance of failure if you start an AI data science project. Okay, so what is actually lean AI? Let's start with lean. So the lean is, the core idea is basically taking from, so you have an idea, right? You create it with a minimum cost, and then you release it as soon as possible. And then, you, for example, in this case, there you have a customer, right? And you want to basically test it out as fast as possible. And the methodology behind that is called Lean Startup. And it's a core component, the core component of Lean Startup is build, measure, learn, feedback loop, and also MVP, so minimum viable product. So build, measure, learn, feedback loop is pretty simple. So the core idea is you build something, right? Like as simple as possible. Then you release it so that the customers can test it out as soon as possible. And then you measure the results of it, right? So some certain KPIs. And then you basically learn from it, like how to improve this. It's a very continuous cycle. The other concept is called MVP, minimum viable product. And every week, so one of my former colleagues says, the minimum viable product is essentially a version of a new product which allows the team to collect the maximum amount of valid learning about customer with the least effort, right? So very simple. So what does it mean? What is actually an MVP? So an MVP is not, for example, when you think about this typical pyramid where you have functional, reliable, usable, emotional design, it's not just functional. So just creating API usually sometimes not just an MVP. And also not an MVP is when you build a full-fledged product, right? Which is functional, reliable, usable, and has an emotional design. The MVP is basically just a subset of all the importance of a product, right? Where it's functional, it's working, right? You can use it, and also it creates like an emotional setting within the product. So in layman terms, so the situation, you are new in Berlin, right? The problem is you need a roof over your head. The question is, what is the minimum solution to solve your problem, right? So the way how you should not do it is, well, you're going to hire an architect, right? And basically plan out a fully fledged nice house in an area that you don't know about, right? So that's like a very high risk that would you do, right? What you should rather do is, and I'll call it MVP for Adventurous People, is, well, you can I mean, no one would do it, but you could basically get a tent, right? And then find a spot somewhere in Berlin and then just settle. But over time, you realize, okay, that area is not really particularly well, and you just need more space. So you could, get a container, and then, over the time, you learn, okay, that is the nice spot in Berlin, right? And this is where I want to settle, and you can get this nice villa. Why is it important? So I'm not quite sure if you know this company, but this company is called Juicero. Juicero, what they basically literally do is they're gonna squeeze juice, right? And they created this very nice fancy machine. Got a very nice funding as well, like 120 million to build this machine. But over the years, when they developed this machine, they failed at basically doing it, because the problem is that the machine is nice, but along with this machine, they basically sold these supplements, right? But the problem is people, when they bought the machine, they didn't really use the machine, because they used their bare hand to squeeze out the juice, because people, just bought the packages because they are quite healthy. And then basically they squeeze out the juice with their bare hands. So they didn't need to pay $700 for this machine to do it for them. Okay, so let's go shortly to the AI part. Well, what is AI? I mean, the AI is from Webster definition, it's a capability of a machine to imitate intelligent human behavior, right? But of course, what we do is not really AI. So this is a quote from Matt Veloso. So the difference between machine learning and AI is, if it's written in Python, it's probably machine learning. If it's written in PowerPoint, it's probably AI, right? So what we actually do is mostly machine learning, or I would say pattern recognition. So why do we need to do lean AI? Well, usually machine learning is part of a product, right? An overall feature within a bigger product. So, for example, let's take this as an example. This is Idealo's recommendation, where basically Idealo is a price comparison, but like it's an e-commerce company, right? And typically what you can find, for example, on Amazon or Zalando and other e-commerce companies, you get recommendation. But of course, this recommendation is not only created by the machine learning team, right? So you need basically UX, UI designers and front-end engineers to create the overall experience, right? You need a backend engineer, right, to solve like a lot of like scaling, right? Because Idealo has like a lot of traffic, right? And then of course you need the intelligence, which is provided by the data scientists and the data engineer. So overall, to create smart product or like a modern product these days, you need a couple of different roles, right? You need data scientists, you need product managers, you need UX UI people, and you need, of course, software engineers. I told you a little bit, I talk a little bit about the build, measure, learn concept, right? Where you have this iterative approach. If you think about a machine learning product lifecycle, it is very similar. So the way how we work is, I mean, if you look at other definitions like Chris or something like that, it's very similar. So you start with a problem, right? And then you have some data, right? And then you're going to explore, review the data. You find out, whether there's some missing values and so on. And then you start to think about, so where does it end up? Is it is it an API, or is it part of a service, and so on. And then you do the modeling, you do feature engineering, right? And then you're going to evaluate the model. And then of course, after you get a nice evaluation of the model, right? The model is working really well. It solves your problem. You're going to put it in production, right? And then of course, when you put it in production, it's usually part of a product, right? So maybe users are going to use it somehow, like maybe internal users or external users, and then these internal external users will provide some feedback, and then of course you will continue to learn again. If you just map the build, measure, learn concept, you can basically the data review, API design, and modeling is the build phase. Then you have the evaluation, which is the measure part. And then basically after putting in production and getting some user feedback, you actually learn something back, right? So it's very similar concept that you can see here. Why is it important? Well, if you can really, use it, like to do it, you can use this concept to reduce risk, right? And basically it is important because if you think about traditional software engineering, right, where I also come from, basically when you do traditional software engineering, you have a lot of risk, right? Because you just build something, it could be like a big monolith, right? And then after some time, you're going to release your first stuff. But in very like agile lean approaches, basically you just release as soon as possible with very small steps, and then take user feedback in. So that kind of reduced risk. Okay, so enough of theory and why is this important. So I'm going to really show like an example where we really use it, and it's a deep learning example. So stay tuned. So basically, it's about text to speech. Okay, what is text to speech? Text to speech is basically about you take a text, right, and then you basically generate a voice like out of it. Why is it important? Well, as I said, we are a media house, right? And in Germany, audio usage is increasing heavily. So if we look at, for example, in the survey, unfortunately, it's in German. You can see the development of audio and video, right? And you can see from 1997 to 2017, the audio usage and also video has increased dramatically. Of course, right? If you think about audio, we have services like Spotify, Amazon, and so on. And also in terms of video, of course, you have services like Netflix and so on, right? But what is more important is also another survey by IID and ZDF, which is our public channels, is about media usage. So they basically surveyed household, and they found out that a typical household spends 87 minutes per week, on internet consumptions, right? So they basically browse or listen to like a music, like a song, right? Or they watch something on YouTube. So, but what's really interesting is that actually out of those 87 minutes, so it's not a subset of it. Or what happened is 42 minutes actually watch something, right, on YouTube. It's clear. I mean, a lot of people, of us either go on YouTube or Netflix and watch something, right? But the more interesting thing is actually a lot of people spend like more than just reading things on the internet. So 38 minutes are listening to something, and only 28 minutes people spend on reading, right? So it's very interesting that people are listening to something more than reading it. The second situation is at the moment, like Axel Springer, we don't really offer a read aloud function. So there's a lot of, like, for example, if you go on micro.sphere.it, so which is another newspaper that we own, basically you can just read the text, right? So you basically have no chance of having the text read out. But our competitors are already using it, and doing it. So, for example, the Frankfurt Allgemeine, which is the FAZ, another competitor in Germany, they're basically using TTS services already to offer read aloud functions, or the Neue Zürcher Zeitung, a Swiss newspaper. But of course, one thing is very important to say: these competitors are actually using like third-party providers, like, for example, Google or Amazon to do it. So our project goal basically was to develop a speech synthesis optimized for journalistic content, right? So in order to produce audio in a scalable way. Why is it important? So basically, of course, we, for example, could hire speakers to read in the text, but the problem is it's not scalable, right? Because every day we have so many new articles coming in. So we need something that is doing automatically for us. And then the second thing is we also, in our case, as I said, the FAZ and the Neue Zürcher Zeitung, they are using third-party providers. We, in our case, we wanted to do it ourselves because it's important technology that we want to develop ourselves, right? So that we don't need to rely on the development cycles of other, I would say, tech providers. This third situation is, why I'm doing this talk as well, is voice was a very new topic for us, right? So there was a lot of risk basically associating with this project, right? Because, it's not only about creating the technology itself, like the text-to-speech component, but also the integration within all the content management systems of all the newspapers. Because the problem within Axel Springer is all the different news vendors, news services, they have their own CMS system. And this is a big problem because how do we integrate it, right? Do we crawl the data and then, put the service on top of that? Or can we provide like kind of an API service on top of this? So there's a lot of complexity involved in this project. And there's this, as I said, two main challenges already, right? Creating a synthetic voice and technical integration. So this is what I already said. Okay, so how do we start? So how we should not solve it is how I want to start with this with the slide. So basically, what you should not do is like when a lot of people are doing that. So they're gonna hire like a bunch of data scientists or also researchers, right, fresh from university, right, and then they just like, okay, we need you guys and just solve the problem for us somehow. But of course, those people, they are fresh graduates. They are maybe very brilliant, right? But they are not really used in a product setting, right? Where basically you need to like think about like what do you create like as a product, right? Instead of like just doing research. Maybe what they do is they just take a bunch of maybe papers, right? Or basically go on Google or GitHub and find something repo, and then they start a code, maybe also from scratch. So this is what I see a lot. And then I see a lot of teams, what they do is, they start to, of course, voice is a very complex topic, right? They start to buy a lot of computing power, like NVIDIA's V100. And you can see, I mean, it's pretty small, but one V100 costs like 11,000 euro, right? And of course, one is not enough, right? You need probably a couple of them, and you spend a lot of money, right? With actually no goal. So this is what you actually shouldn't do. So how we actually solve it is, as I said, deep learning or in machine learning, there's a lot of problems that are kind of solved already, right? Not everything is solved, but a lot of problems are solved in some way, but with a certain degree of basically maturity. And what you should do is you shouldn't really reinvent the wheel in this case. So what happens is, as I said, deep learning or TTS, text to speech. There's a lot of people already in the research community that is doing that already. And at the moment, the most state-of-the-art approach is using deep learning. So what happens is basically as an input, you have a text, right? In this case, I love news and artificial intelligence. And then you also provide the wave file, the audio file with that. And what we do then is we convert the audio file in a spectrogram model. So it's a mellogram. Basically here, it's another representation of how sound or voice can look like, right? So as a feature. And then what happens then is you're gonna train a model that predicts, right, or generates this mellogram. And out of this mellogram, you need a vocoder. A vocoder basically is converts the mellogram back into voice, right? So typically, if you're mathematicians, can think as an inversion of a function, right? And a voice model usually in the past, what basically happened is you can use like Griffin Lim. So Griffin Lim sounds like that.
I love news and artificial intelligence.
Did you hear it? Okay. Maybe give a feedback. Okay, I think you hear it, right? And then what also can be done is basically using like, of course, it didn't sound really good. It was very robotic. And now what people do is they use another deep learning approach, deep learning vocoder. In this case, we use WaveRNN basically to convert it into voice. And this sounds like that.
I love news and artificial intelligence.
So it sounds much more human, right? Okay, so in terms of how we did the project is, as I said, very iterative as well. So what we do is we start with researching the topics. So it took us, in the case, 2 weeks, but actually we had already some time before. That's why I put the 1 month in quotation mark. And then we trained our first open source model on open source data. So this is very important to say it because what I see in a lot of people doing is, okay, they're going to start with training a model, right? But they don't really look for open source data, but they, just basically maybe sometimes create their own data already, or they have a data set. But it's better take something that is already there, right, and then just train it on that. And then what happens is we collect our own voice data, and then we train it on a custom model, and then we productionize it, and then refine it, and then we do it again and again. So this is the first result with our open source data. Basically, what we did is we took data from it's called the Abenteuer des Odysseus, so the Adventure of Odysseus. It's a book for children, and then basically we train it on German text. Unfortunately, it's in German, so but maybe you speak German.
Daher peitschte ihn von Süd nach Nord, von Ost nach West auf dem weiten Meere umher. Er zertrümmerte seine Schiffe, tötete seine Gefährten und führte ihn durch Strohhöhe und Klippen zu Völkern, deren Sitte und Sprache ihm fremd waren.
So, I mean, even though you wouldn't, if you don't understand German, I think it sounds already really nice for like a first text-to-speech model. What happens then, of course, I mean, as I said, we're following this lean startup approach, right? So we basically deployed this model like internally, and then like for example on this article by Welt.de. So it sounds like that.
So verteidigt Merkel die Einschränkungen der Grundrechte. Anlässlich des Jahrestages der Verabschiedung des Grundgesetzes bezeichnete Bundeskanzlerin Angela Merkel die Einschränkung von Grundrechten in der Corona-Krise als Zumutung, die allerdings trotzdem notwendig gewesen sei.
Okay, I'm going to stop here, but as you can probably already hear, it sounds very, very boring, right? I mean, if of course, from some people it sounds nice, but for me, it's like, we did a little survey, right? How it would sound. And, it's not the nicest voice if you like a news reader, especially when you, for example, want to read out a sports article, right? So what happens then is we start to collect our own data, right? So we surveyed out a couple of speakers that are interesting for us. And then we source the data, we gave the speakers our data as well, so that he reads out articles from our articles, because in machine learning, it's important that you basically train a model, right? And then fine tune it on your own data so that it works well in your own data. And this is basically how it would sound with our voice now.
So verteidigt Merkel die Einschränkungen der Grundrechte. Anlässlich des Jahrestages der Verabschiedung des Grundgesetzes bezeichnete Bundeskanzlerin Angela Merkel die Einschränkung von Grundrechten in der Corona-Krise als Zumutung, die allerdings trotzdem notwendig gewesen sei.
Okay, I will stop here as well. So, of course, it was very important that, for this project, so in order to see if we are successful or not, right, you really need to compare it against other providers, right? And so we did a little survey within Axel Springer. So 70 people actually answered back, and basically we gave them a couple of articles, right, read out by different providers in our voice, right? And then, of course, we didn't name that this was voiced by Microsoft or Amazon, but without any labels. And basically, the most important message here is that our voice got a very high mean opinionated score, right? So we got a 4.0, which is quite good. And of course, you can expect it a little bit because our voice was trained on our own data, right? So if you have a voice that is trained on your own data, you get all the things more right than if you have a more general approach on voice. Then of course we compared also our speech synthesis in against our competitors, so against especially the FAZ. And this is an article from the FAZ, and this is how it sounds.
Corona-Intensivstation. Sie haben einen sehr langen Weg vor sich. Wenn Corona-Patienten auf der Intensivstation aus dem Koma erwachen, sind keine Angehörigen da, um die Erinnerungslücken zu schließen.
And as I said, they're using Google, so it sounds quite okay. And this is how our sound.
Corona-Intensivstation. Sie haben einen sehr langen Weg vor sich. Wenn Corona-Patienten auf der Intensivstation aus dem Koma erwachen, sind keine Angehörigen da, um die Erinnerungslücken zu schließen.
And that was our voice. So it doesn't sound so bad if you compare it to Google's TTS. And the cool thing is, so our MVP, so it's already live on Welt.de. So it took us around 5 months basically to, from from the R&D, right, to creating, the first models, right, sourcing our data, retraining it on our custom voice, right, with our own models as well, right, until we put it also to production, right. So, and basically you can go on this Welt article here as well, and then also see how it would actually sound. The second point, what I would mention is also use the cloud, right? Because in the earlier slide, I said that some teams, they start to buy on-premise hardware, right? But the more important thing is sometimes you don't have a feeling what kind of on-premise hardware you should buy, right? Especially in the case of text-to-speech, because text-to-speech actually needs a lot of computing power. And, if we, just buy hardware and we don't know it, right, we would spend a lot of money and we probably would kind of misuse the data. In this case, for example, it takes like almost 480 hours to train on, for example, an NVIDIA 2018 Ti, right, 48 hours. And for voice model, you need another 1,000 hours, which is circa 42 days. After 24 hours, it would sound like that. So you can, you can hear a little bit of how it would sound after certain hours. So after 24 hours. So it's German, but even though you would speak German, you wouldn't probably understand anything. This is after 42 hours.
Ich liebe Nachrichten und künstliche Intelligenz.
This is after 66 hours.
Ich liebe Nachrichten und künstliche Intelligenz.
So you can hear it already a little bit. So it says, ich liebe Nachrichten und künstliche Intelligenz. So I love news and artificial intelligence. And after 200 hours would sound like that.
Ich liebe Nachrichten und künstliche Intelligenz.
Okay. And because we use the cloud in the case, so we use a lot of stuff on AWS, we would probably, a little bit guess, the complexity. And because of that, we could guess, hey, do we kind of train it continuously on AWS, or do we need to buy our own hardware? And in our case, we decided to buy our own hardware after 1 month, because we knew that, hey, training it on AWS will be very expensive for us. But then, after, because knowing what we actually need, in terms of computing power, do we need a lot of memory, right? Or do we need a lot of memories? Do we need multi-processing, right? We could understand it much more because we already tested on AWS, right? So spending the money on AWS basically give us a better estimation on buying our own premise hardware as well. Okay, so I'm going to finish the presentation. So as I said, I give a little bit of theory, like what is lean startup, right? And basically how you can use it to minimize risk, right? In case, because, machine learning, as I said, is part of a product. It's not standalone usually. And basically I also showed how, this build, measure, learn feedback concept kind of is very similar to a machine learning product lifecycle. And then very important, so stay lean in AI, that's what I call. So don't reinvent the wheel. So there's a lot of things already out there, right? So if you start with the project, don't start from scratch, but, look what's already there, and then, build on top of that. Deploy as fast as possible. This is very important message because, a lot of people, they wait until they got the best accuracy, the best evaluation metrics, but then the problem is you don't really need it for some certain use cases. And then, of course, harness the power of the cloud, right? So don't, buy on-premise hardware if you don't really know what you want to use. Very important thing. So out of this project, we actually released 2 open source projects. So the first one is for Chakotron. It's inspired by a paper by Microsoft. But basically, what we use is we use the Chakotron as well, similar to Microsoft, the concept, but when we added basically the length regulator. So the fast speech is actually using transformers. So I got it a little bit wrong. So in for Chakotron, basically what we did is instead of using transformers, we use Chakotron, and then we added a duration predictor and a length regulator on top of that, which works really, really well. And then also we release Transformer TTS, which basically use transformer instead of tachytron. And then we also added another kind of like a fast speech layer on top of that as well. So if you are interested, check out our open source projects. They are well documented. You can also try out like few of your texts on a Google Colab notebook, but also you can train your custom model as well. All right, that was my presentation. So I'm going to probably leave the sharing.